pronounce your last name? I want to know how close I was.
Oh, I don't know if you want to hear it.
I do want to hear it. I want to hear it.
It's Mytrofanovska.
Mytrofanovska. Okay.
Yes, yes.
Now you wait. Your turn.
No, I'm good. I literally just had like a weed eater or a gardener just go past my window. I turned my mic off real quick, but so I've given you presenter. You have full
Yes,
rights.
I
Right? Cool.
started sharing.
We still have 4 minutes, so we can sit and just talk and have fun for 4 minutes.
Sure, why not?
We are having so much fun over here. We were trying to figure out what Wade's Russian name would be earlier. I told him if he had been in Russian class, the teacher probably would have called him Vlad. It's probably the closest I can think of.
Yeah, and actually Vlad has different different full names. So Vlad can be Vladislav, or it can be Vadim, but it's not Vlad, it's like Vadik, I guess. So yeah.
You get your choice.
Yes. I can be called like Nastya, Anastasia, Stasia, Stacy. So it's too many. It's too many. It's many options. Yeah.
It's one of the fun names for sure.
Yeah. But it's not Russian. It's Ukrainian.
Oh, it's Ukrainian.
Yes.
Did not know that. I definitely thought it was Russian because of like, Grand Duchess.
Slavic names are like similar, so yeah.
Yeah, they're all very similar.
Good
stuff. Actually, what's surprising about Russian is that there's a lot of cognates to French because of that whole period where they were trying to be Western European and they stopped speaking Russian and they wanted to only speak French, and then it didn't quite work. And then the next generation rose up and we're like, no, we're Russians and we're going to speak Russian. But by the way, did anyone write any of that down? Because we're missing a lot of words. And so they just filled it in with like, Cyrillic spelling of French words.
And basically, I don't know if Russians speak French good right now.
So they went
who
off
knows?
and really forgot the French, which is good.
Yeah.
Your own. Oh, IPv6.
Yes.
I'm not gonna
we have
lie.
no warning on what any of the talks are about, so it's just as a surprise for us.
It's kind of like luck of the draw over here. I'm not gonna lie, I've been avoiding the IPv6 train like the plague because I'm like, I do not need one more thing. I do not need one more thing.
Yeah, and it's more confusing when you know IPv4, when you know when you know the structure, when you know how it works, and then bam, IPv6, more numbers, and they even have like words in that, and oh my god,
you threw letters in there. It's twice as long.
Yes.
I don't understand what. No, I don't like it.
I'm pretty sure I failed the IPv6 part in Network Plus, so that just shows.
If I ever encountered an environment that was all IPv6, I would just quit the pen test. I'd be like, no, I'm done. I don't know what I'm doing.
Ooh, that's good. That's good security then. I'll start implementing that then. Switching everything to IPv6.
Have a lot of learning to do because we don't like change. We're like, you don't have AD? No. Can you implement AD? Because we could mess that up really easily, but we don't want to play with Okta.
Yeah, in future you can add. And can you implement IPv6, please?
Like, yeah, we have no AD in IPv6. I'm like, I'm out. I quit. Here's your deposit back. Nope. No.
Ooh, I know there's a couple big companies out there that have said they've implemented it completely.
Oh.
But I think it's just like Bing, right? So like Google.
Google, Facebook, I guess.
Yeah.
Just creative training. I need to take it. I need to take it so bad.
All right. Well, here we go. Good luck. I'm sure you don't need it.
All right,
Thank you.
The stage is yours.
Yay. Hello, GRIMMCon. Hope you are doing great today, and thank you everyone who came to listen to me, and thank you GRIMMCon for giving me the opportunity to speak today. My main goal of this presentation is raising awareness of using IPv6, and that's why I want to talk about it in a context of cybersecurity. So, small introduction first. My name is Stacy, or Nastya, or Anastasia. You can choose more convenient for you. I already have my master's degree in information system security, and I've been working as a security analyst in a SOC team for almost a year. Today, I'm going to cover a bit of IPv6 introduction, types of IPv6 addresses, how to get and implement IPv6 at your home environment, and also reconnaissance in IPv6 networks. Every device in the internet is identified through its own internet protocol address in order for internet communication to work. And actually, that can be compared with zip codes and street addresses you need to know in order to mail a letter. IPv6 is the latest version of the internet protocol, and IPv4 is the version that we are all familiar with more. The addresses look different. Within these protocols. The IPv6 has 128-bit addressing scheme, what means that it consists of 8 groups of 4 hexadecimal digits with the groups separated by colon. And for comparison, the IPv4 has 32-bit addressing scheme, so it consists of 4 groups of decimal digits with the groups separated by dots. But the key difference between the versions of the protocol is that IPv6 has significantly more address space. To make our lives better, IPv6 addresses can be shortened. And let's take a look on some examples. So first, if they're a string of zeros, then you can remove them. You can only do this once, and your IPv6 device will fill up the remaining space with zeros until it has 128-bit address. Then, if you have a hexadet group, that means a group of 4 hexadecimal digits with 4 zeros, then you can remove those and leave a single zero. And again, your IPv6 device will add the remaining 3 zeros. And finally, leading zeros can also be removed. And eventually, by removing these zeros, we get a nice short IPv6 address. IPv6 is very important for the long-term health of the internet. There are only about 3.7 billion public IPv4 addresses, and this may sound a lot, but it isn't even one IP address for each person on the planet. And considering people have more and more internet-connected devices, the lack of IP addresses is already proven to be a serious problem. This may not affect those in well-off developed countries just yet, but developing countries are already running out of IPv4 addresses. And the expanded addressing capacity of IPv6 enables supporting connectivity for a huge range of new devices, such as phones, laptops, IoT devices. Also, eventually, unbelievable amount of IP addresses gives an opportunity to get rid of network addressing translation, or NAT. And that actually means that every device has its own public address. IPv6 public addresses are more known as global unicast addresses, and they are equivalent of the public addresses in IPv4 networks. Global addresses are routable on the internet. But does it mean that IPv6 has no private addressing? Well, as you can see on the slide, it doesn't. In IPv4, internal addresses use the reserved number ranges, and these addresses are not routed on the internet and reserved for internal networks. IPv6 has 2 internal address types, link local and unique local. Link local addresses are used to communicate between hosts on the same link. They are meant to be used inside an internal network. They are not routed on the internet or even internal network. they're restricted to a particular physical link, which is an electronic connection between our devices. Also, link local addresses are self-assigned. That means they do not require a presence of a DHCP server in the network. Unique local are meant to be used inside an internal network as well. They are not routed on the internet, but they are routed on the internal network. Basically, they are equivalent to the internal IPv4 addresses. But according to my research, unique local addresses are not yet commonly implemented. So I mentioned before that with IPv6, we don't need NET anymore. But you may have questioned, won't my network be less secure without NET? Translating addresses does not provide any security benefits. And in many cases, NET require an outgoing connection to be present before it will allow an incoming connection. And this stateful packet filtering can be enabled for IPv6 too. Also, IPv6 makes possible end-to-end connection without intermediate devices, and that can hinder man-in-the-middle attack, for example. I know you've been already thinking, how can I use IPv6 in my home network? Can I implement it by myself? Of course. First way to do that is asking your internet service provider for IPv6. And for example, on the World IPv6 Launch website, you can check providers that joined IPv6 launching and can provide you with IPv6 address. But what if you don't have a provider in your city that supports IPv6? And by the way, that's exactly the situation I have, because I don't have any IPv6 provider in my hometown. And that's not a problem because Hurricane Electric exists. It is a global internet provider that provides IPv6 as well. And you can just fill out the form on Tunnel Broker website and get yourself global IPv6 with 64 subnet mask free. But what 64 subnet mask gives us? Well, it gives us an opportunity to have a subnet with that amount of addresses. And I know that's impressive. So now is the main question. With that amount of addresses and subnets that the person or organization can have with IPv6, is it even possible to make network reconnaissance in IPv6 networks? I mark that as yes, but it's not that simple. The scale of the address scanning task is so large in IPv6 that attackers must be very creative to be good enough. And simply sweeping an entire 64 IPv6 subnet would just be impossible. But that doesn't mean that we cannot use patterns or documented techniques for example, white or gray box pen test techniques. And some note, white box pen test techniques involves sharing full information and system, full network and system information with a tester. In a gray box, only limited information is shared with a tester. And there is also a black box pen test where no information is provided at all. So first thing we need to take into account is patterns. They are used in infrastructure networks to simplify the management so it can be easy to remember. And what we can use, the first thing that we can use, it's a low byte addresses in which most of the bytes are set to 0 except for the least significant byte. Also, there are IPv4 based addresses in which the IPv4 address is embedded in IPv6. And I know it looks weird, but that exists and there's nothing we can do about. Also, we can use service port addresses. It's simply a using of TCP or UDP port of the main service running on that host. And also wordy addresses, which encode words. Let's move on to techniques. If the target is a local network, the following techniques are found to be effective. And I'll cover a bit later local address scanning and traffic snooping. On the other hand, if the target is a remote network, these techniques on the slide may be used, and I'm going to describe in more details DNS brute forcing, remote address scanning, and DNS reverse mappings. Let's start with DNS brute forcing. It's actually the easiest one. This technique may be employed just by looking for DNS quad A records against commonly used host names. Quad A points a domain name, and quad A record points a domain name to an IPv6 address. For this purpose, we can use common scanning tool called InMap. It has a nice feature called InMap script engine, so we can download DNS brute script and use it with InMap. Firstly, let's deal with some terms on that slide. A DNS pointer record, or PTR provides the domain name associated with an IP address. And in our case, PTR record is exactly the opposite of the quad A record, which provides the IP address associated with a domain name. The domain name ARPA is a top-level domain in a domain name system, DNS, of the internet. An IP6.ARPA zone is used for mapping IPv6 addresses to internet domain names. And what is the most interesting about this technique is that it can greatly reduce the IPv6 address search space. Basically, we can walk through the IP6 ARPA zone corresponding to a target network and issuing queries for PTR records corresponding to the domain names. And if there were PTR records for any host starting with the domain name, the response would contain a code of 0. That means no error. Otherwise, the response would contain a code of 4. We can try PTR scan within map as well. There is another script for that called DNS IP6 ARPA scan. Also, we can just use some of the web tools. For example, this one is a reverse DNS tool on Network Tools website. Before address scanning, you should consider which subnet prefix to choose. A typical site might have 48 or 64 subnets to be scanned. And however, we can try to reduce the search space by guessing likely address plan schemes or using any clues that might exist from other sources or observations. And for example, there are a number of documents available online, like RFC 5375, that provide recommendations for the allocation of address space. And address plans might include addresses that run from low number upwards, use building numbers in hexadecimal, decimal form, or use VLAN numbers. The Scan6 tool from IPv6 Toolkit supports sweeping address ranges and can also use all the address patterns. And this tool can be found in default repositories on Debian-based systems. What about local networks? Firstly, we can try to obtain information via traffic snooping, aka sniffing. This can help in discovering active hosts in a number of ways. Firstly, each captured packet will reveal the source and destination of the packet, of course. Secondly, the captured traffic may correspond to network protocols that transfer information such as host or router addresses, network topology information, etc. IPv6 address scanning in local area networks to some extent could be considered a completely different problem than scanning a remote IPv6 network. The main difference is in usage of link local multicast addresses. This is a replacement of IPv4 broadcast addresses, and multicast is a group of addresses, but not all addresses in a subnet. And such multicast addresses can relieve the attacker of searching for unicast addresses in a large IPv6 address space. So an attacker can simply send probe packets to the all nodes link local multicast address and get a reply from all active hosts. But I want to emphasize one more time, this can help with discovering link local addresses only. So it will work only in the private networks. There are a variety of publicly available local IPv6 network address scanners. Current versions of Nmap implement this functionality. Also, a Live6 tool from IPv6 Attack Toolkit implements this too. And also, it can be found in repositories for Debian-based systems. Also, I want to mention V. They are computer science PhD students who work in on IPv6 scanner for their PhD project. And this one helped me a lot to find a right path for my talk. And I found very helpful the materials about IPv6 security that we shared on their GitHub as well. So I highly recommend to check out the Twitter account because we post their research updates there as well. Let's move to mitigation part. IPv6 address scanning attacks can be mitigated in a number of ways. First thing that we can do is to limit pattern addresses. Then we can try to employ intrusion prevention systems or to enforce IPv6 packet filtering where it's possible, of course. We can try to avoid use of sequentially addresses when using DHCP v6, and ideally the DHCP v6 server would allocate random addresses from a large pool. We can use the default 64 size IPv6 subnet prefixes, and in general, just avoid being predictable in the way addresses are assigned. What about block listing? IPv6 hosts are generally able to configure any number of IPv6 addresses within their 64 local subnet. And in the event of malicious activity, you should blocklist at least the 64 from which you have detected malicious activity. And depending on the specific provider, internet provider, the attacker might have control of prefixes of any length between 48 and 64. So if malicious activity persists after blocklisting the offending 64 subnet, you may want to block shorter prefixes, hence larger blocks of addresses. In this example, I used IP6 tables, which is IPv6 version of IP tables. And IP tables is a Linux command line utility to manage the IP packet filter rules. What else we can do or we should know to be able to secure ourselves? First of all, knowing the syntax makes it much easier to quickly know how to deal with a security breach or implement necessary measures. And as you can see, the syntax can be confusing because of the shortening techniques that I mentioned earlier. Hit the off button. Shutting off IPv6 capabilities when you are not using it may seem obvious, but it may not be that easy because a number of programs have already been configured to work with IPv6, and just as many may already have the protocol turned on automatically by default. So please check, double check, and triple check your environment to ensure IPv6 is enabled only when it is used. Even with large portions of network disabled for IPv6, there is still the threat of unwanted IPv6 visitors. And when that happens, organizations should know how to kill it before it can infect others within the network. This is the situation where knowing IPv6 syntax can be useful, particularly for setting up effective firewalls and traffic filters. What continued IPv6 adoptions means for internet security? Um, Attackers tend to set their sights on new targets only when they become worthy of their attention. And the same goes for IPv6. As IPv6 adoption becomes more prevalent, threat actors are increasingly using its addresses as an attack vector. If threat intelligence feeds haven't prepared to analyze IPv6 addresses, they are faced with big black holes in their datasets, and the ability to monitor anomalous web traffic is one of the keys to detecting a breach. Coming to the end, I want to say that device producers should also be aware of IPv6 adoption. This is especially true for IoT devices. The amount of internet-connected IoT devices grows exponentially, so millions, even billions of new IP addresses will be needed. And IPv6 will help with that, but manufacturers should make sure their devices are designed with the capabilities to support, analyze, secure it. And IPv6 may have been a long time coming, but it's too late in the game to ignore. On this slide, you can find links and tools that you might have missed, and also where you can find me to have a chat. I'm always glad to learn by helping people and resolving interesting cases. And I want to say special thanks to Margaret, Sertag, the Digital Orders community, and of course, GRIMMCon for support and for the feedbacks. I'm ready for your questions.
All right, we do have at least one, and that was how can oh my gosh, wait, I lost it. Everyone, this is my fault completely. It was a bit up. What are the methods an organization can use to implement IPv6 if that's something that you
do? Yes, we can do that in our environment, and there are at least 4 methods for approach that the organization can use to migrate to IPv6. Like we can use just native implementation, so just using IPv6 without IPv4 support. We can use IPv6 tunneling. It's just a tunnel for in IPv4. So roughly speaking, it's something like an VPN. So you establish a tunnel between your end device with IPv6 and the end device, like for example, your web server or something like that. Also, we can use Net64. It's just the translation IPv6 address to IPv4 address in case if your server or your device that you are going to connect to doesn't support IPv6. I guess that's it.
So that was so awesome. I feel like
Thank you.
I was sitting here like
Insights.
like good God, I've avoided this for so long. But like this is one of those things, you guys, that if you don't understand it, you just got to break it down into its teeny tiny, easy to digest bits until it's something that you're comfortable with. What is one of the reasons you would advocate going to IPv6 over IPv4?
You mean
like completely adopting it? Why is it better? Why is it?
Actually, the secure part of IPv6 is like the securing of IPv6 is better because, for example, IPv6 supports end-to-end encryption. We familiar with IPsec protocol, and you can use it with IPv6 because IPv6 is supported by default. So we can use end-to-end encryption like automatically, and even don't bother about it. So yeah.
Go ahead, back your slides up to the one where so people can contact you. So we can get you all them.
The
Sure.
handle slide.
Yes. Oh, and also I will be active in Discord, GRIMMCon Discord, like an hour or two. So if you have some questions, you can send me right away.
See, we got any more questions? Have you come across any tools that you haven't been able, or any tools that haven't been able to convert to IPv6 that were critical? Like,
actually, I faced with implementation IPv6 in my home environment. I was trying to use the IPv6 from tunnel broker, but and when you're trying to implement that in your own environment, they have the examples for different operational systems and devices, how you can implement that. And I was trying to do that on my Mac, and interestingly, that I couldn't do that. Even I didn't get any errors. I even used Wireshark just to find out what was the problem, and the packets will go away to the IPv6 server, but I didn't get any replies, and I'm still investigating. I've been still investigating what was the problem with that. But I think it may be it may be simpler with some Linux devices or Windows.
okay, I definitely want to set up, go grab some addresses and set some stuff at my house now that I know that.
Yeah, but you should probably have a static IPv4 addresses and open a CMP port and open, if I'm not mistaken, the TCP port 40 for the establishing IPv6 tunneling.
Okay. With besides just that Mac problem, did you have any other big concerns or big problems when setting it up at your house?
No. The main problem is always the syntax.
Okay.
So I think in many organizations, many of us avoid IPv6 because they don't know how to migrate, or they don't know how to implement it correctly, or how to set up firewalls correctly. So yeah.
Okay. I got one good one. Is there any configuration that where something can go wrong? So say the sysadmin configures something wrong in IPv6 that would leave a big security hole. Something that one that you can just
you tell us.
Actually, your devices, I think, already support link local addresses, even if you don't know that. So, for example, if if an attacker, cyber actor, managed to connect to your home environment, they can establish, they can find out all of your link local addresses, and they can even establish the IPv6 tunnel without without any footprints in your I don't know, maybe some detection systems.
Sounds like persistence on a platter to me.
Yeah.
right up your alley. See, have you encountered any exploitation of IPv6 in the wild in your work?
Not yet. Not for now.
It's always golden until the first one.
Yes. Exactly.
Long-time blue teamer. I have not as well. Meryl, you got anything over there?
Not that I'm going to tell you about. That's for me to know and you to find out.
What led you down this IPv6 rabbit hole? Why'd you focus on it?
Because eventually we will use the IPv6. Like, there's not any way back. And we need to start to learn that now before it will be like widespread. For example, according to Google statistics, IPv6 implemented for implemented for like 35% for 2021 year, and grows like 10% for like each 5 years, I guess. So it's not a long way.
Okay.
Do you think eventually, so like, how's that going to work? Are they just eventually going to push IPv4 out? or like, are we just gonna like stop? Like, our ISP is just gonna stop providing it? Like, how is this gonna? Is it gonna go away, or are we still gonna have it like behind like NAT gateways, or
I
how is
think that would be approached smoothly. Like I said, there is a couple messes like IPv6 tunnels that I mentioned before. So you can use an IPv6 and IPv4 both. Oh, and I forgot to mention there is a dual stack settings for your routers, so you can use an IPv4 and IPv6 simultaneously. So not without tunneling, just like two separate routes.
I'm afraid. I'm afraid for IPv4 to go away. I'm afraid.
It's not going to happen in 5 years or 10 or 20, I guess.
I know, but still, one day I'm going to call for support. Someone's gonna be like, what's your IP address? And be like, here we go.
Yeah.
I just imagine like copying IPv6 addresses into like my Splunk searches or virus,
yeah.
right? Like it used to be so easy. I could just memorize an address real quick and type it, but one day I'm gonna get that super long IPv6 address that doesn't have any of the truncated shrinking to it.
We need to have a separate database for all IPv6 addresses. Yeah.
There's gonna come a day where I'm gonna be looking and be like, oh my god, it's C4 octets. Oh my god, there's an IPv4 over here, guys. And we're gonna be like, I remember those golden days when you only had 4 numbers to memorize.
So Johnny did recommend a web app, a Chrome app, browser plugin, whatever, called IPv4.
Oh, nice name. I haven't heard about it.
Fool?
It looks interesting. Not fool. Foo.
Oh.
Foo, like Foo Bar?
Like Foo Fighters?
Foo Fighters, yeah.
Yeah, but I'm just calling it fool because like we're all fools when it comes to IPv6, except for Anastasia over here.
I'm still a fool, you know.
Okay.
Oh, if you want to learn more about IPv6, I would recommend to not underestimate RFC documents.
That's
because I know not so many people who would actually read them. No, why?
YouTube channel? Maybe this is a good learning opportunity, Meryl. Meryl, you want to do a Perl site on IPv6? There you go.
Maybe we need to. Maybe it's time. Only I'm gonna have them call her to do it. Like, yes, teach me everything you know about IPv6 so I can go make a course on this thing. But you know what, we're gonna
teach me like a course.
We are gonna have to start working on IPv6 like exploit and post-exploit tutorials. That's gonna need to come next.
Precisely.
Yeah, teaching people how to break it so we can test it on our own. Oh, the day is coming. All right. Well, thank you so much to Anastasia. You can feel free to hang out with us. We have Gabrielle coming up at 1:15 or 10:15 if you're Pacific. I know everyone's all screwy with their time zones. So we have about 12 minutes until she shows up.
I think I'm gonna drop off because actually it's my working day today, but don't tell my boss, please.
I think we tagged you on Twitter. I'm so sorry. I hope your boss doesn't have Twitter.
That's okay. They don't know I have a Twitter.
The day my bosses found on mine, I was like, damn, there it goes.
Yeah. So have fun. Take care, guys.
So much. That was
thank
like
you.
the most important thing I've learned this year, I think.
Thank you, guys. Take care.
All right. Bye-bye.
Bye.
Bye.